Hello dear students, good morning. Welcome back to the chemistry class. In the last class, we have discussed a few numericals on depression in freezing point. In today's session, we will discuss the next concept, that is the fourth colligative property, osmotic pressure. So let's take the next heading. The fourth colligative property, osmosis and osmotic pressure. Osmotic pressure is the fourth colligative property which we are using to determine the molar mass of the solute. Now, before discussing the osmotic pressure, let's try to understand what is meant by the process osmosis. So here, the first point, osmosis. What is meant by the term osmosis? In our real life, day-to-day life, we have come across with the many examples. When a wilted flower is placed in the water, it revives. Simple. When an egg is placed in the normal water, it swells, its size increases. When the same egg is placed in the salt water, it shrinks. So here, in this process, the movement of water molecule takes place through some membrane, some surface, the membrane. So this movement of water molecule, solvent molecule, from one region to another region, from one part to other part, is termed as the osmosis. For example, let us consider a sugar solution. Sugar solutions taken in the crystal flask and which is placed inverted. So this is the water molecule, water beaker. In this, I have placed a crystal flask inverted. This is the crystal flask. It is placed inverted and the bottom of this flask is covered with, a semi-permeable membrane. This is covered with a semi-permeable membrane. This is SPM, semi-permeable membrane. Semi-permeable membrane. Now it containing water. In the crystal flask, I have taken the sugar solution. So this is sugar solution I have taken. This is the initially the level of sugar solution. Now, after sometimes if it is observed, what happens? The level in the crystal flask, it is increased. So this level increases. This level in the crystal flask, it is increases. So up to this, now the sugar solution is diluted. It becomes diluted. So this is the initial sugar solutions I have taken and it becomes diluted. So what happens is, why the level in the crystal flask increases? In the beginning, look at this. This is the concentrated solution. I have taken the solution I have taken, and this is a solvent. This is the solvent. In the beginning, when it is placed, the level of the solution is up to this point. Now, when the solvent molecules which enter into the crystal flask through the semi-permeable membrane. Now let us define what is meant by this SPM. Semi-permeable membrane means what? A very simple definition. This is a membrane. Semi-permeable membrane can be defined as, it is a membrane which allows the passage of solvent molecules only, but not the solute. So this membrane allows the movement of passage of only solvent molecules. It do not allows the solute particle to pass through it. That is called semi-permeable membrane. Is it clear? The membrane, so here you can note this definition. So semi-permeable membrane is nothing but this is the membrane which allows the passage of solvent molecule only. Solvent molecules, which allows the passage of solvent molecules only, but not the solute particle. So here, when it is placed, the solutions, the concentration of water inside the crystal flask and the concentration of water outside the crystal flask is different. So here the water concentration is less and here the water concentration is more, because assume that I have taken 1 liter of the solution, 1 liter of water solvent, 1 liter 1000 ml. Now 50 ml of solution I have taken in this flask, 50 ml, that means sugar plus water together, sugar solution, the solution volume is 50 and solvent is 1000. So solvent molecules is more here. So therefore the water molecules which moves from beaker to crystal flask, as a result the level of the solution increases. It gradually increases and after some times when it reaches the equilibrium, so an equilibrium pressure is when it reaches the equilibrium at a particular height, it stops. So at this point, the inflow of solvent molecules which stops. Why it stop? Because as you know that when the level increases, when the height increases, the pressure also increases on the SPM. So when pressure increases, so this pressure which stops the inflow of solvent molecules, so this is the concept of osmosis. So can we define now? Yes, osmosis is nothing but it is the process of movement of solvent molecule from its higher region to lower region, or simply we can say movement of solvent molecule from solvent to solutions, from osmosis. Osmosis can be defined as it is the process of a movement of solvent molecules, because movement of solvent molecules from solvent to solution, or in other words we can say the movement of solvent molecule from its high concentration to low concentration, or we can say the movement of solvent molecule takes place from low concentrated solution to high concentrated solution. You are confusing, right? Yes, you are confused because I am saying that it's high concentration to low concentration, but yeah, here I am writing low concentrated to high concentrated. So in these two definitions, look at carefully. Osmosis is nothing but, so for example, if I am taking only the solvent and solutions, let us take a compartment. It is separated by a semi-permeable membrane. Second one, same it is separated by semi-permeable membrane. In one case, I have taken pure solvent. Pure solvent. In the second case, I have taken the solution. In the second case, I have taken the solution. So here it is solution and it is solvent. Whereas in this case, I have taken 2 molar solution and here 20 molar solution. Assume that I have taken 2 molar solution and 20 molar solution. Yes. What is meant by osmosis? Osmosis is nothing but the movement of solvent molecule only. Osmosis is nothing but the process of movement, of solvent molecules from the process of movement of solvent molecule. ಎಲ್ಲಿಂದ ಹೋಗುತ್ತೆ solvent molecule from solvent to solution. So this is the direction from solvent to solution. Because second line from its high concentration, that means which one? Water, that is solvent. The movement of solvent molecule from its high region, its high concentration means where the solvent concentration is more. So here the solvent concentration is more. So movement of solvent molecule from its high concentration to low concentration. Now suppose if you are taking the solutions, 2 different solutions I have taken. So in the first case, I have taken one is a solvent and second one is a solution. Therefore, in terms of solvent to solutions are from its high concentration to low concentration, I can say. Suppose if 2 different solutions are used, in that case what happens? So if 2 different solutions I have taken, assume that the one is 2 molar and the second one is 20 molar solution. So in 2 molar, by definition of molarity, what is the meaning of 2 molar and 20 molar? 2 molar is nothing but 2 moles of solute is present in 1 liter, right? In 1 liter, 2 moles is present in 1000 ml, 2 moles. Whereas in this case, 20 moles is present in 1000 ml, 1 liter. Look at this. In 1000 ml, out of 1000 ml, 2 moles of solute is present, remaining is water. Whereas in 20 molar, 20 moles of solute is present, remaining is water. Now you can predict in which case the solvent concentration is more among these two. Solvent concentration is more in which solution? In which solution the water is more? Definitely the low concentrated solution. Low concentrated solution, dilute solution means water level is more, water concentration is more, solute concentration is less. So from low concentrated solution, look at the term, low concentrated solution means water level is more. High concentrated solution means solute concentration is more, solvent concentration is less. So therefore we can define the osmosis as it is the process of movement of solvent molecule from solvent to solution, or it is the process of movement of solvent molecule from its high concentration to low concentration, or it is the process of movement of solvent molecule from low concentrated solution to high concentrated solution. This is through semi-permeable membrane, through SPM, through semi-permeable membrane is called osmosis. The movement of solvent molecule takes place through SPM, semi-permeable membrane. So here for SPM, some of the examples you can note, examples for semi-permeable membrane. So natural semi-permeable membrane, natural, synthetic semi-permeable membrane, synthetic and artificial semi-permeable membrane. Natural semi-permeable membrane is animal bladder, animal bladder or parchment paper. Whereas synthetic is cellophane membrane is a synthetic one. Artificial is cupric Cu2 ferrocyanide FeCN6. Cupric ferrocyanide. It is cupric ferrocyanide. Cupric ferrocyanide. These are the examples of SPM. So now the one concept, the basic term is clear, that is about osmosis. What is meant by osmosis? It is the process of movement of solvent molecules from its high concentration to low concentration, or solvent to solution, or low concentrated solution to high concentrated solution through semi-permeable membrane. Now, what is meant by this semi-permeable membrane? So this semi-permeable membrane is nothing but it is a membrane which allows the passage of only solvent molecules but not the solute. It is known as a semi-permeable membrane, and these are the example. Natural semi-permeable membrane is animal bladder. Synthetic is cellophane. Artificial is cupric ferrocyanide. These are the example of SPM. Now let's come to the point. What is meant by the term osmotic pressure? Because osmotic pressure is a colligative property, right? A very simple definition for this. See here, when the level increases in the crystal flask, it stops after some times. At this point, at this equilibrium point, whatever the pressure exerted in this flask, so it's just enough to stop the inflow of solvent molecule, right? So this pressure is nothing but osmotic pressure. How to define? The pressure which is required to just stop the flow of solvent molecule, inflow of solvent molecule, or we can say to stop the osmosis. The pressure which is required to stop the osmosis, the pressure required to stop the osmosis is called as osmotic pressure. Osmotic pressure. Is it clear? Osmotic pressure is nothing but it is the pressure required to stop the osmosis, to stop the inflow of solvent molecule is known as osmotic pressure. So its definition is clear. It is represented by the symbol pi. Osmosis definition and osmotic pressure definition. So it is the pressure required to stop the osmosis. The pressure required to stop the osmosis, or the pressure which is applied on the solution side to stop the inflow of solvent molecule, or to stop the movement of solvent molecule from solvent to solution is called as osmotic pressure. Now the most important is osmotic pressure is a colligative property, we are saying. Why it is a colligative property? So here the Van 't Hoff observed that this osmotic pressure is given by pi is equals to CRT. So the osmotic pressure is equals to C, that is concentration, where C is concentration, R is universal gas constant, T is a temperature at a given temperature. So C is nothing but concentration. So pi is the concentration means number of moles of solute divided by some volume of solutions, RT we can write. So R we can write pi is equals to pi into V, pi V is equals to nRT also we can write. So moreover, at this a particular temperature, R is also constant, T is also constant, therefore pi can be written as pi is directly proportional to C. Pi is directly proportional to C, where C is concentration. Which concentration? It is molar concentration. Molar concentration. In the remaining three colligative properties, in RLVP, we have used XB, mole fraction of solute. In elevation in boiling point and depression in freezing point, molal, that is molality, small m we have used. But in osmotic pressure, we are using capital M, molarity, RITY, molar, LAR. In the previous, LAL, molal, it is molar. So, molar concentration. Since this osmotic pressure is dependent on the molar concentration of solution, so therefore it is a colligative property. Irrespective of its nature, it depends only on the molar concentration of the solute. So therefore, pi, that is osmotic pressure, is a colligative property. Now, how to determine the molar mass? So let us see here. Molar mass can be determined by, so by this equation, where n is nothing but what? Number of moles of solute. Very simple equation. Pi V is equals to, in place of n we can write number of moles. In place of number of moles, given mass by molar mass R into T over. I want to find the molar mass of solute. So therefore, molar mass of solute is equals to WB RT divided by pi V. Remember, the volume is in liter. If volume is given in terms of ml, then you need to multiply it by 1000. So WRT by pi V, where V is volume of solution in liters. If it is given in terms of ml, then you need to multiply or you need to convert into liters, because molarity definition, number of moles of solute present in volume of solution in liters. If it is in ml, multiply this by 1000. Right. So this is the fourth formula to find the molar mass of solute from osmotic pressure. Osmotic pressure. Is it clear? Is it clear? Yes. So this is the concept of osmosis and osmotic pressure. So we have discussed regarding the osmosis, semi-permeable membrane, example, and osmotic pressure definition. So why the osmotic pressure is a colligative property and how to determine the molar mass of solute. So this is the concept we have covered in this class, right? So the remaining few concepts on osmotic pressure will continue in the next class. That is about what is meant by the reverse osmosis, what are the biological significance of osmosis and osmotic pressure, how to purify or desalination of water, that is reverse osmosis, its application, and some numericals will continue in the next class. Okay, right. So in today's session, just we have covered the concept of osmosis and osmotic pressure. We'll continue in the next class.